Hey guys, so I'm going to talk to you about the 5 types of reactions. Last week we learned how to balance reactions, and we're going to revisit that in just a little bit. But there are, this is Unit 5, and there are 5 types of chemical reactions. So you need to copy all of this, and this first part doesn't really look like notes, but it is because reactants are on the left side of the reaction arrow. And what you see on the right side of the arrow, those are called products. So that's going to be used in these definitions, descriptions, and so you're going to need to understand what each of those means. So, for the 5 types of reactions, as you are copying this, I'm going to go ahead and explain these. So the first type of reaction is called a synthesis. And a synthesis, if you see me side-eyeing people, there are people in the classroom, and they were instructed to be really quiet, and I think they're testing my patience, but I'm going to keep going. So a synthesis is a reaction where you have more than one reactant, okay, and when they combine, they only form one product. All right, so in this example, we have only one product that I have boxed in, and I want to point out what may be obvious, but might not to everybody. So I want to point out that here we have this reactant, which is magnesium, reacting with something else. This little plus here is separating 2 different reactants. Now there are numbers in front of here to balance it, but that doesn't mean that there's 2 reactants. The reactants are separated with the plus, okay? And then we have only one product. There are 2 of them that are formed, but only one product. If we had another one, it would be plus something else. All right, so that's a synthesis. One product is formed. And then we have a decomposition. So a decomposition is the opposite of a synthesis. You start out with one thing, and just like decomposing, same root word, you are breaking down into multiple pieces. So a decomposition has only one reactant, okay? And that's actually the same exact reaction, just written in the opposite order, all right? Now number 3, my favorite. Combustion. You've got what is being described as a hydrocarbon. Y'all don't have to memorize these definitions. So a hydrocarbon is just C something, H something, okay? Reacting with oxygen, because you got to have oxygen for any kind of combustion, which is like a fire. But what you need to really know is it produces the same 2 products every time, carbon dioxide and water. So when you're looking at your reactions, if you see carbon dioxide and water only as the products, that's a combustion, right? And then we have type 4 and type 5. So reaction types 4 and 5 are both replacement reactions. You're going to see 2 reactants, 2 products, all right? But if it's a single replacement, you're going to notice that you have one element that is by itself or single on each side of the reaction arrow. On the reactant side, we have calcium. On the product side, we have hydrogen. This is still just one element, even though there's a subscript of a 2, okay? And then for double replacement, you have 2 cations switching places. That actually happens here also. Calcium is by itself, and hydrogen is with chloride. But over here, you have hydrogen by itself. Calcium, then, is with chloride. But over here, what's different is you have a compound and another compound, and then your 2 products are also compounds. There is no one element by itself. And remember, a single element is one capital letter with possibly a lowercase letter or just a capital letter by itself. So that's our 5 types of reactions. So I'm now going to go to today's practice work, and I'm going to use some of that as an example of how to apply this. Okay, so for this example, we're going to look at this practice sheet that you guys got, I think, last time we were doing this. All right, because if I tell you the day, it's not going to matter because it's a video. So you've got 2 different strategies to do this. You can go number 1, number 2, number 3, and go in numerical order. Or you can look back at your notes, and you can see that you wrote down some descriptions, ways to identify the 5 types of reactions, and you can start with synthesis first. So 2 different strategies. If I were the student, I would look for the synthesis reactions first, and then I would look for the next one, which is decomposition, and go like that. I'm not going to do that with y'all because I have to show you an example of each. So here's my strategy. By the way, so for synthesis, it said that we are forming only one product. So we're going to look at number 1, and I want you to notice that in number 1, I have 2 things on the reactant side, and I only have one product. You are not going to like draw all over these, but since I'm doing this to illustrate, I just want you to see there's only one product. So clearly this one is a synthesis. In the directions, we don't have to write the word synthesis to the side. We can just make an S and then move on to the next one, okay? But again, if I was the student, I would just go through and look at all of these and try to find any of them that only have one product. And go ahead and identify all the synthesis reactions and then look for the next type. For the video, I'm just going to show you one of each type. So then I'm looking at number 2, and I see that I have one reactant and I have 2 products. So what kind of reaction has only one reactant? Well, guess what? Conveniently, it's the second type. It's decomposition. So I want you to look at this. There's only one reactant. That is a decomposition. Okay? Moving on to number 3. This is yet another reaction type. Again, you guys are not actually going to go through and highlight all that stuff, but I'm just trying to draw your eye to that as I'm teaching it. So in number 3, we have 2 reactants, 2 products. Combustion is going to have carbon dioxide and water, so I don't see that. So this is either single or double replacement. Notice that we have fluorine by itself over on the reactant side and chlorine on the product side. So this is single replacement. Number 3 is single replacement. Number 4, we've already done one of these types, so I'm going to skip down to number 5. And for number 5, I have 2 reactants and 2 products. I don't have carbon dioxide and water as my products, so it's one of the replacements. So I'm noticing that everything is a chemical compound. I don't have an element by itself, so this is clearly a double replacement. All right? And then the last reaction type would be a combustion. So a combustion is always going to form carbon dioxide and water as products. That is going to be like number 7. So it is a combustion, and I just write a letter C there. So you can literally go through all 30 of these and identify them. Number 17 is a little tricky. There won't be one like that on your test, but if you have questions about that, you can ask me. Okay, so that is identifying reactions.